So this session about the projectile motion in an inclined plane. Okay. So last session it was with the the horizontal line. Now this projectile plane is inclined and making an angle alpha with the horizontal. So this is the horizontal line. So this is the plane of projectile and having an alpha with this plane, right? Now what happened in this case? The equations will be changed. That means that earlier whenever we did the projectile motion with the horizontal line with no inclinations, that time the range was with no accelerations. The horizontal motion was under uniform velocity. Now in this case, when the projectile plane is in inclination, that time you are getting an acceleration in both the direction, both in vertical and the horizontal. So at this time the horizontal acceleration will be the g sine alpha. So that's we are saying ax is equal to minus g sine alpha. So whenever you are solving any problem in the projectile motion in a plane, inclined with the plane, you have to consider four things, that is ux, uy, ax, ay. So ux, uy means we are throwing the object with this angle u, the theta, angle theta with this plane of projectile. So ux will be in this direction, uy will be in this direction. So ux will be u cos theta, uy will be u sin theta, right? So we write here ux u cos theta, uy u sin theta. Now next is the acceleration. Now if you see here, the vertically downward, this is the acceleration due to gravity, right? So this vertical is actually the g, right? G is acting here. Now this g is having two components here, right? So that is the g cos alpha and the g sin alpha. Earlier we have seen in that friction problem that was mg in mg cos theta, mg sin theta. Now here if g is the vector, it's having two components. One is the g cos alpha, one is the g sin alpha. If this is angle alpha, then this will be the g cos alpha. So you can see that the vertical component of g with respect to this plane is the g cos alpha now, right? And the horizontal component of the acceleration due to gravity in this plane will be g sin alpha. Now g sin alpha is acting in this direction. So if I am taking this is as a positive, if I told you the right direction as a positive, so g sin alpha will be negative. So we took ax is equal to minus g sin alpha. Then ay. So we took ay is like in the vertical direction. So directions of ay here will be from here the vertical, right? Vertically upward. So this is ay. So ay is minus g cos alpha, because g cos alpha is actually acting this direction. So this will be the ay minus g cos alpha, right? So these four are very key concept for this motion. Rest of the things is same like earlier. So for vertical motion, a is equal to ut plus half h square. So vertical motion, vertical distance we took as an y or h. ut, u is the uy is this one, right? ut plus half h square. Now a means ay. So we took ay as a minus g cos alpha. That's it. So your equation is ready for the vertical motion. And for the horizontal motion, x is equal to uxt plus half axt square. You just put the value here, you will get the details, right? So in the vertical motion, we see that in the top position, at this position, the velocity will be 0. So you will get the total time of flight. Okay. So I believe that it will help you. Follow my session. Next class I will come with the other problems. Okay. Thanks for watching my session.